Hello class. Today we are looking at section 9.6, radical equations. Turn to page 694 and let's look at a little vocabulary. You have the power rule. It says if x, y, and n are real numbers and x equal y, then x to the nth power equals y to the nth power. On page 695, it talks about solving an equation containing radicals. And you have 4 steps there. So please make sure you read those 4 steps. And we will be demonstrating those steps in our notes today. I also want to talk about a vocabulary term that is called extraneous solution. We have talked about this term in previous chapters, but we want to remember that an extraneous solution is a false solution. So an example of an extraneous solution can be a case where 2 equals 3. And we know that 2 does not equal 3. That is an example of an extraneous solution. So we will run across a few of those as we work on our notes today. Let's turn to page 699 and we're going to look at number 17. It says solve each equation. 17, I have the square root of 4x plus 5 equals 3. And if you have looked at those 4 steps in solving a radical equation, the first thing says to isolate one radical expression on one side of the equation. If you notice, the square root of 4x plus 5 is already isolated and it equals 3. So we're good on that step. Step 2 says raise both sides of the equation to the power that is the same as the index of the radical. Now we know the index is understood to be a2. So to get rid of that square root, we have to do the inverse, which is we have to square both sides. When we square both sides, that gets rid of the square root. We are left with 4x plus 5 equal 3 times 3 is 9. After this, we can now solve a 2-step equation. We have 4x equal 9. If I move the plus 5 to the right, it becomes minus 5. You have 4x equals 4. Divide both sides of the equation by 4. The 4's cancel to 1. So x equals 1. Now, when you're dealing with these types of equations, you do want to check these because you can possibly run across some extraneous solution. On this one, if I was to plug 1 back in, 4 plus 1, 4 times 1 is 4, and 4 plus 5 is 9. And we know the square root of 9 equals 3. So the left and the right side equal, that means that 1 is the solution. Let's try another example. Let's look at number 19. 19, if you notice, it has the square root of 4x minus 8 plus 4 is outside of that root and it's equal to 10. Now remember what the 4-step process says. The first step says to isolate one radical expression. If you notice, the plus 4 is also to the left of the equal. I need that plus 4 to the right side of the equal. To move the 4, I'm going to do the additive inverse. So I'm going to subtract 4 on both sides of my equation. 4 is equal to 0 here. They're opposites. I'm left with the square root of 4x minus 8 equals 10 minus 4 is 6. Step 2, it says raise both sides of the equation to the power that is the same as the index. My index is the square root, a 2. So I raise both the left and right side to the power of 2. To get rid of that square root, I am left with 4x minus 8. 6 times 6 is 36. And we can just solve for x now. So add 8 on both sides of my equation. And of course, you have your calculator handy. Add it up right quick or just apply those mental math skills. I have 4x equal 44. I'm going to divide both sides by 4. So x equals 11. If I plug 11 back into my original problem, it will equal 10. Okay, let's try one where we have an extraneous solution. Let's try one of those and see how that works out. Let's look at number 25. It says, solve each equation, identify any extraneous solutions. So let's try this. We will have a extraneous solution on this one. So let's see how that looks. Number 25. The square root of 2y minus 5 plus 4 on the outside of that radical equals y. I do want to move that forward to the right side of my equation. So I have the square root of 2y minus 5 equals y. That plus 4 moves to the right of the equation and becomes minus 4. Now, I have isolated one of those. I have isolated the square root. So now we want to square both sides. I am left with 2y minus 5 equals, and if I notice here, I see y minus 4. Going back to our very first chapter, we have a base raised to the second power, so we have to write that base out twice. And we're going to do full method, or you can apply the box method. And we have done plenty of notes on those two methods. Now, I do want to finish reading the rest of our steps. Step 3 says solve the resulting equation. If it still contains a radical, go back to step 1. And then step 4 says check the possible solutions to eliminate the extraneous ones. So we're on step 3 now. It says solve the equation. I see no more square roots, so I can solve for y. 2y minus 5 equals, I'm going to apply the full method. So first, y times y is y squared. Outside, y times negative 4 is negative 4y. Inside, negative 4 times y is negative 4y. And last, negative 4 times negative 4 is positive 16. Okay? Now, my degree is 2. We know degree is the highest exponent. That means I'm going to have 2 answers. When you have your degree, you want your leading coefficient, which is understood to be positive 1. You want your leading coefficient to stay positive. So I'm going to take the 2y and the minus 5 and move it to the right of my equation. I'm going to say 0 equals y squared. I know negative 4 minus 4y is negative 8y. Bring down that plus 16. If I move the 2y from the left to the right, it becomes negative 2y. And if I move that minus 5 from the left to the right, it becomes positive 5. Now, I have moved everything to one side of my equation. Let's now simplify a little more. I have 0 equal y squared. Negative 8y minus 2y is negative 10y. And then 16 plus 5 is negative 21. And again, always double check your math to make sure you add and subtract everything correctly. You'll be fine. It should be plus 21. Okay, so now I see a trinomial. So when I see a trinomial, I know that I can factor. So let's factor. Very, very important that you know how to factor. We have 0 equal, and I'm going to factor. I know y squared is y times y. I need to find two factors that will multiply to give me 21 and add to give me 10. I know that 7 times 3 is 21. I know negative 7 minus 3 is negative 10. So we are good. Since we have it in factor form, we can now solve for y. So y minus 7 equals 0. And y minus 3 equals 0. Y equals 7. And y equals 3. Now, one of these solutions will be extraneous. So you can have a case where all the answers are extraneous, or all the answers could be the solution. Or you may have a case where only one answer may be extraneous. So both of these can be extraneous, or one could be extraneous, or both answers are the solution. But again, when you're dealing with radicals, you see a square root, cube root, fourth root, you do want to check those solutions to make sure that they are the solution to this problem. Now, what I would do is I'm going to take the 7 and plug it back into the original radical to see if the left side equals the right side. And then I'm going to take the 3 and plug it back into my original problem and see if the left equals the right. So let's check that right quick to see what happens. So again, on 25, we had the square root of 2y minus 5 plus 4 equals y. Now, one of my answers was 7. Everywhere I see y, I'm going to plug in 7. Two times 7 is 14, and 14 minus 5 is 9. Plus 3 plus 4 equals 7. So I'm just making an assumption that the left side equal to right. I don't know yet. The square root of 9 is 3. Plus 4 is 7. 3 plus 4 is 7. So 7 is a solution. So for number 25, 7 is a solution. Now let's check 3. I have the square root of 2. I'm going to plug in 3 for y minus 5. Bring down that plus 4 equals 3 again. And I want to see, does the left side equal the right side? I know that 2 times 3 is 6. And 6 minus 5 is 1. And then bring down that plus 4. And we're assuming that it equals 3. The square root of 1 is 1 plus 4 equals 3. Now 1 plus 4 equals 5. Does 5 equal 3? No, it does not. So the way I would write this answer, 3 is not a solution. 7 was. The way I would write this final answer, and this is the way the textbook does it, I would say 7, 3 is extraneous. And we know 3 was extraneous because we know 3 does not equal 5. 3 will never equal 5. So that is very, very easy to do. So that concludes this section on how to solve those radical equations. If you have any questions or concerns, please let me know. Very important that you study. Make sure you practice plenty of these, and make sure you understand the definition of extraneous solution. Make sure you read those 4 steps on how to solve radical equations, and make sure you understand that definition again.